Bismillahirrahmanirrahim. Rounding a bank curve. For a car traveling at certain speed, it is possible to bank a curve at just the right angle so that no friction is needed to maintain the car's turning radius. Then a car can safely round the curve even on wet ice. Your engineering firm plans to rebuild a curve so that a car moves at a chosen speed v can safely make the turn even with no friction. At what angle beta should the curve be banked? We have to find the banking angle beta. While a car takes a turn, it executes a circular motion at this point and it has some radial acceleration in it, so we will use the Newton's second law of motion. First is to identify the relevant concept, and we have identified that Newton's second law of motion will be applied and the target variable is the angle beta. Next step is to set up, and this is the simple sketch, and next we have to make a free body diagram of this car. So we place a dot on it and there are two forces acting on the dot. First is the weight acting downward. Second is the normal reaction. So this is the slanting curve and this is normal, and normal reaction is parallel to this normal, and this normal reaction makes angle beta with the vertical. There are two components of this normal reaction n. One is along the perpendicular, that is n cos beta, and other component is n sin beta, that is perpendicular to it. And we have to attach set of coordinate axes. We place x-axis along n sin beta because in this direction the radial acceleration acts and radial force also acts in this direction. Perpendicular to it we place the y-axis. Next step is to execute. First we will apply the Newton's second law of motion as sigma fx is equal to ma radial. Sigma fx sum of all the forces along x-axis, and there is only a single force that is acting along x-axis is n sin beta. So sigma fx is equal to n sin beta is equal to ma radial. This is equation number 1. Next we will apply the second law of motion along y-axis. Sigma fy means n cos beta is positive and mg is negative. So n cos beta minus mg is equal to m into a radial. The acceleration along y-axis is 0. As there is no motion of the car along y-axis, so we will get the value of n from here. N is equal to mg over cos beta. Putting this value of n into equation 1 here as mg over cos beta into sin beta is equal to ma radial. After simplification, this is mg tan beta is equal to ma radial. And as the a radial is equal to v square over r, mg tan beta is equal to mv square over r. Here the tan beta is equal to v square over gr. From here we can find beta is equal to tan inverse v square over r. In order to evaluate this target variable, banking angle depends upon velocity and radius. If we put the value of velocity as 25 meter per second and value of r as 230 meter, this is usual calculation in our everyday life, then we will get the angle beta as 15 degree. So this is the usual angle for the bank curves. So our calculated target variable is correct. Thank you very much for watching this video.